The problem is called number of connected components in an undirected graph. And if we see some of the popular companies who have already asked this question, there are companies like TikTok, Amazon, Google, Facebook, LinkedIn, Microsoft, DoorDash, and Twitter. So this problem has been really popular amongst topmost companies. And let's see that what the problem statement is trying to convey. Basically, this is a LeetCode medium problem and also very well-liked problem. It says that we have a graph of n nodes that we are already given, and we are basically given the edges that defines that there is a connection existing between those two nodes for any given graph. Now, based on that, we need to indicate that how many number of connected components are present inside the graph. So let's try to understand this with an example. In this case, currently we have 5 nodes. So basically we are given an n is equal to 5 as the number that defines that there are 5 nodes. We are also given these edges. So we would have given 3 entries, and the first entry is going to be 1 to 2, second entry is going to be 1 to 3, and third entry is going to be 4 to 5. Now based on these two items, we need to define that how many number of connected components that exist, which in this case we can see that this is the first connected component because these 3 nodes are connected with each other, and same way this is the second connected components. So in this example, for this given input, we can define that there exist 2 connected components and we need to return 2 as the answer. So this is the whole ask of the problem. Let's try to understand this with one more example. Suppose in this case, currently we are given n is equal to 7 and we are given all of these different edges. Now in this example, we can clearly see that there exist 4 different connected components, and those 4 components are these, that this is the first one, this is the second one, this is the third one. And though this 7 is not connected with any other node, still this is a connected component in itself because it's connected with itself. So in this case, in total, since we have 4 connected components, we need to return 4 as the answer. Now let's see that what is going to be the strategy to solve this problem. Suppose we take the same example as the input and we will try to see that what should be the answer. Now again, remember, we are given 2 things. First, we are given n is equal to 7, so that we know for sure there exist 7 nodes, and we are given all of these 5 edges. Now based on these number of nodes and edges, we can clearly do one simple thing, and that is to treat this as a graph problem, because that what it is. Basically we know that a graph is comprised of 2 items. First one is a node and second one is an edge, and which we are just told in plain English that these are the 2 entities we are given. So we are going to treat this one as a graph. Now the aim is to find connected components, which means from any single edge or any single node, we will need to define that how many other nodes that particular node is connected with. And if we keep on repeating the same process, and the moment we find the connected nodes, we can eliminate all of those nodes. So and repeat the process for all the 7 nodes that are given, we would be able to find the number of connected components quite easily. And the technique we are going to use over here is the one of the most popular technique in the entire coding industry, and that is called breadth first search. And how we are going to use BFS? Well, we already know that in order to use BFS, we will have to use Q, and we will also have to use number of visited nodes that we have already visited. So using these 2 items, we are going to make our lives so much easier, and let me just walk you through the solution. First thing we are going to do is we are going to we can start from any node, because this is a graph. There is no particular definition that we need to start from here or we need to start from here. Say for simplicity, we start from this node number 0. So we are going to have our queue. Now inside our queue, currently we don't have any elements, and we also have our visited hash set. We can also use visited array. I'm just giving you example of visited hash set. Either way, we are going to have a mechanism to keep track of all the numbers or all the nodes that we have visited so far. So this is our visited hash set, and this one is our queue. Okay. Now first we start with node number 0. Now for node number 0, we are going to mark this one as 0. So we are going to enqueue with 0. Now we are also going to mark 0 as visited. Okay. And we are also going to have one more number that is called the number of connected components. So let me just mark this one as counter. Okay. And currently the initial counter value is going to be 0. But since we found one node, we know for sure that there exists at least one connected component, because it could be connected to itself. So in that case, we are going to increase the number by 1. Okay. Now for this particular 0, we are going to run BFS, and by running BFS, what we would be able to do is that we would be able to go through all the neighbors that the 0 is connected with, and then mark all of them in the visited hash set. So even in the future, for this n is equal to 7, if we come back to the same node, if that node has already been visited, we will just simply skip over it. So let's just do that. Now for this 0, it has two neighbors. First neighbor is neighbor 2 and neighbor 1. Currently both are not visited, so let's just add entry 0, 1 and 2 over here, and then we will mark 1 and 2 inside our queue, because we need to do something with that. Currently the count is still going to be 1 because all the nodes are connected. Now we pop 0 out and we do the same process with 1. Currently for the value number 1, 1 is also visited. So since 1 is already been visited, we do not need to do anything with 1, and we can simply pop that one out. Again, 2 is also visited, so we do not need to do anything, and we can pop it out. Now after iterating or after doing the BFS starting with the node 0, we have simply eliminated node 2, node 1 and node 0 by itself, and so far the count has been 1, and we have all of these 3 nodes in our visited hash set. But we know that there are still 7 nodes that we have to take care of, so we are going to iteratively go over every single one of them. Initially we started with 0, so we got rid of it. Let's just start with 1. Again for 1, since 1 has already been visited, we do not need to increase the counter and move on to the next value. Again 2 has also been visited, so we do not need to increase the counter and move on to the next value. So all of this entire connected component has been taken care of. Moving on to the next value, starting at position number 3. Since 3 has not been visited, adding 3 over here, adding 3 in the queue as well, going through all the neighbors of 3. Currently 3 only has one neighbor, and that is value number 5. 5 is not being visited, and also since we find a new element 3, I forgot to add the increment the count. So now the number of connected components we have found so far is going to be 2. I forgot that, but this is important. Now going back, the currently 3 is connected with 5. 5 has not been visited, marking 5 as visited, at the same time adding 5 inside our queue to visit further neighbors of 5. Now 3 does not have any more neighbors, which means we can get 3 out or dequeue 3, and then we are going to have value number 5 remaining. 5 has one neighbor, that is 3, but since 3 has already been visited, we cannot do anything with that, so we are also going to get rid of 5, and 5 has also been taken out. This means that currently we do not have any elements inside our BFS function. Now moving on, currently we went through 0, 1, 2 and 3. Now we need to go through value number 4, because there are 7 elements inside our given input. For even again repeating the same process for value number 4, currently 4 has not been visited, so we will mark value number 4 as visited. At the same time, we are going to put 4 inside our queue. We are going to go through the neighbor of 4 current, and we are also going to increase the count. I always forget to increase the count, which is the most popular thing which is the most important thing asked in this problem. But anyways, now going back for value number 6, it has not been visited, so we are going to add value number 6 over here, at the same time add value number 6 over here. Now we iterated over all the neighbors of 4, so we are going to dequeue 4. After dequeuing, currently there is only element number 6 staying in. 6 currently has one neighbor, that is value number 4, but since 4 has already been visited, we do not need to add it to our queue, and then eventually we would pop out 6 as well. Now what we have done is that currently, in order to find these 3 connected components, we already visited nodes 0, 1, 2, 3, 4, 5 and 6, and all of these nodes are visited. Now in the end, we are going to be at the position number 7. Since for position number 7, this node has not been visited, which means we need to increase the counter. So currently the counter is going to be of value number 4. Now we are going to add 7 to our list of visited nodes, and also we are going to mark 7 inside our queue. Since 7 does not have any neighbors, which means we can pop 7 out immediately, and now our queue is empty. We have already iterated over all the number of 7 nodes that were given as the input, and we are basically done with the problem. So in the end, whatever the value that has been stored inside this count variable is the answer we need to return. So simply at the end, we can return that there are 4 connected components in this problem. And this is the complete solution. Now, if you see how beautifully we were able to come up with the solution, and in this case, if you see time and space complexity, the time complexity is going to be big O of V plus E, where V defines the vertices or nodes, and the E defines edges, because that is the time complexity to run the BFS function and go over the entire given input array. So this time complexity is pretty good. If we see space complexity, now space complexity is also going to be big O of V, because we are using the additional data structure of Q and also a hash set or a array. There are two ways to do it. I typically like to use hash set, but you can also use an array as well. Both would work equally fine. In either case, this is a very good time and space complexity. And remember, the one of the most important concept is, inside the graph theory, the breadth first search allowed us to solve this problem smoothly in a beautiful manner. Here is the coding solution for number of connected components in an undirected graph, where first of all we are given in the input the value n, and we are also given a 2 by 2 array called edges. So first thing we are going to do is create an adjacency list and to create a graph like structure. So this is going to allow us to iterate over graph in a much easier fashion, which this process is doing, where we are running across every single edge and every single node and plotting them on the graph. After that, we are going to have our boolean array called visited, and we are also going to have a value called count that initially we are going to set it up as 0. We are going to run our for loop starting from value 0 to the total number of n that is given in the input. And then inside the for loop, first thing we are going to check is that the current ith position, if that is not visited, then we are going to call our BFS function, and at the same time we are going to note it as the new connected component found, and we are going to increment the number of count. Now let's see that what is going to happen in our helper method BFS, where we are taking a graph as the input. We are also taking the number of nodes that have been visited so far, and we are also using the starting pointer from which we are entering inside this given graph. So first of all, we are going to initialize our cube. We are also going to have a visited array that we are going to mark as true for the current node that we are visited. And while there are no entries inside the queue, first of all, we are going to pop the last added element inside the queue, visit every single neighbor of that node, and for all the neighbors that has not been visited, we are going to mark them as visited, and we are going to add it to our existing queue. And by doing this operation, we would be simply running through every single connected component. So suppose here I give you like 0 as the input, then through this BFS method, 0, 1 and 2, all three nodes would be marked visited because they all are connected. And this is what this operation is doing. And in the end, after this for loop ends in our main method, we simply need to return the count that we have found that would allow us to find the number of connected components. Let's try to run this code. And our solution works perfectly fine. Let's submit the code. And our code runs decently efficiently. And don't worry about that you are not being able to see the code. I'm going to put this code inside the GitHub, so you would be able to find it quite easily from there.